Welcome back, class. The video today is to check your work from lesson 91. Okay, so you can get something to mark your paper with. As we go through and check the problems, make sure you understand the procedure. Okay, if there's something that we go over and you still don't understand it, feel free to send me an email. In your email, give me a phone number where I can reach you so I can call you so we can try to talk through the problem so you understand it better. Okay? Okay, so check your work here from lesson 91. Number 1 was one of our favorite types of problems. What are these average problems, okay? It says that the average height of 6 paintings was 86 centimeters. So I said, well, average is a division problem where the average is the answer. So if I know the answer and I know how many I divide by, I multiply them together to get the total. Okay, so 6 paintings together totaled 516 centimeters. The other 4 averaged 94 centimeters, so I multiplied 94 times 4 and I got 376 centimeters. Then they want to know the average height of all 10 paintings. So I added 376 centimeters and 516 centimeters. I got 892 centimeters. I divided by 10 and my final answer was 89.2 centimeters. Make sure to pause the video anytime that you need to write some of this stuff down. Number 2, it says how much bigger is the mean than the median. So I wrote my numbers in order. Okay, then I started counting off to get my median. It was 2 numbers in the middle. So I averaged those 2 numbers, so my median was 11, or rather 8 for the median. Then I had to get the mean, so I had to add all my numbers together. I got 88. I divided by the 8. That's how many numbers there are. I got 11 is my mean. Okay, so it says how much bigger is the mean, so I said 11 minus 8, and the mean is 3 bigger than the median. Number 7 was our next one. This was one of our percent and actual problems. Okay, so it said that 40 people came to the party. That was 80% of the people that were invited. So my categories, I said people that came, some didn't come, and then I had the total. Okay, so it asked me what was the total number of people that were invited. So I know that if this number was 80%, the total number of people invited was 100%. That means the ones that didn't come had to be by 20%. So I can get rid of this category. Okay? So my proportion was 80 over 100 is equal to 40 over my total. I did my cross multiplying, and my total was 50. 50 people invited. Number 10. 3/4 of the exhibits were physical science. 3/4. So I made a diagram. I divided it into 4 pieces. It said 3/4 of those were for physical science and 60 projects were for physical science. So I said 60 divided by 3 is 20. That means 20 goes in each of my blanks. In A, they want to know the total number of projects at the science fair. My total number is 80. In B, it says what percent were not about physical science. Well, if these ones were about physical science, this is the one that's not about physical science. That's 1 out of 4. 1/4 is 25%. Number 11. This is one of our newest types of problems, okay? We had to evaluate. So they gave us x minus y minus xy, and they wanted us to use -3 for x, -2 for y. Okay, so I replaced every x with -3 and every y with -2, and I kept them all in parentheses to help. So now I have -3 minus -2 for y minus -3 times -2. Okay, my order of operations says I have to do this multiplying first. -3 times -2 is +6. Then I rewrote -3 minus -2 minus +6. So now I need to fix these subtractions to algebraic addition. Instead of subtracting here, I'm going to add. The opposite of -2 is +2. Instead of subtracting here, I'm going to add. The opposite of +6 is -6. So now I have all addition. So now I can just do my same sign, add and keep, or opposite subtract. -3 plus a +2, this is opposite, so I subtract a 3 and a 2. That's a 1. I keep the sign of the bigger one, so it's -1. Then I can add my -6. Same sign, add and keep. My result, final answer, -7. Number 12. This is one of our newer types of problems as well from our investigation. This is an inverse relationship. If I have 3 painters, it takes 12 hours. So how many hours does it take if I have 4 painters? Okay, I have more painters, so it's going to take less time. Okay, so this was one of our work hours problems. So I need to see 3 painters times 12 hours gives me 36 work hours. Okay, it's going to take the same amount of work hours in this case, but I've got more painters. So 36 is equal to 4 times some number of hours that those 4 painters are going to take. 36 divided by 4 is 9 hours. Okay, number 13. We've got this shape that they gave us. Okay, they're telling us, oops, I didn't put my right angles in here. The first thing they said is to name the shape. This is a trapezoid, one set of parallel lines. Okay. B, they asked for perimeter, so I added all my outside lengths, 60 millimeters. C, they asked for the area. I have to know my area of a trapezoid formula. Base 1 plus base 2 divided by 2 times the height. Remember, my bases are the sides that are parallel. Okay? And then this is my height because this forms a right angle with my bases. So I did 15 plus 20. I got 35. Divide by 2, that's 17.5 times 12. That gives me 210 millimeters square. In D, it says that this interior angle here is 75 degrees, and it tells us all of the interior angles have to add up to 360. Okay? So if I know this one is 90, I know this one is 90, I know this one is 75, angle D, the last one, has to be 105 degrees. Next, we've got multiplication in scientific notation. I'm going to do 2.5, or rather 2.4 times 5 first. That gives me 12. 10 to the 4th times 10 to the negative 4 times 10 to the negative 7. Negative 4 and negative 7 combine to make negative 11. Oh, 12 is not in proper form. 12 needs to turn into 1.2, but I got to show that it originally was 12, so I say 1.2 times 10 to the 1st. Then I bring back in my times 10 to the negative 11. Final answer, 1.2 times 10 to the negative 10. Number 17, we've got this figure, right? We've got our pyramid with a square base. Okay, pyramid with a square base. Faces, 1, 2, 3, 4, 5 faces. Edges, 1, 2, 3, 4 along the bottom, 1, 2, 3, 4 along the top parts. That's 8 total. Vertices, 1, 2, 3, 4, and 5. Now we've got a circle. We need to find the circumference and the area. Circumference, pi times diameter. They gave us the diameter. They said to use 3.14 for pi. When I multiply those, 25.12 centimeters. Okay? Formula for area, pi times radius squared. Well, if the diameter is 8, the radius is 4. So I did 4 centimeters times 4 centimeters. I got 16 centimeters squared. Multiply it times 3.14. And our final answer is 50.24 centimeters squared. Okay, next we have a graphing problem. Okay, this is like we just did in our investigation. They want this x-axis to be our yards and the y-axis to be our feet. They asked us to plot these points, 1, 3, 2, 6, 3, 9, and to draw the line. Okay, so your graph should look like my graph. Let's see, and then B, it says, B, does the graph show a direct variation? Well, let's remember what our graph has to look like to show a direct variation. It has to be a straight line. Do we have a straight line? Yes. And it has to go to or through the origin. Yes. If I have 0 yards, I'm going to have 0 feet. So 0, 0 is part of the graph. So now we have this angle problem, right? I've drawn what is in your book, okay? At first they want us to find the measure of angle X here. Well, if this measures 90, and this measures 30, and this is a triangle, 90 and 30 add up to 120, that leaves us 60 degrees left for angle X. So angle X is 60 degrees. Angle Y is a vertical angle to angle X. So they have the same measure. So angle X is 60 degrees. Angle Y is also 60 degrees. Now they want to know angle A, the measure of angle A. Here's another triangle. If I add 60 and 65, I get 125. They have to add up to 180. 180 minus 125 is 55 degrees. D says, are these triangles similar? Remember, similar triangles have to have this, their corresponding angles have to have the same measure, right? Well, this over here is a right triangle. For them to even start being similar, this one would have to be a right triangle, and it's not. So that told me real quickly that these weren't. Plus, the corresponding angles are not similar or equal. Okay. Next, number 21, the A part. Negative 3x minus 3 minus x minus 1. We need to combine what is like. Here's a term with an x. Here's another term with an x. Negative 3x's, if there's no number, it's a 1. Negative 1x, negative 3 and negative 1 make negative 4x. Now I have a negative 3 and a negative 1 that are like. Negative 3 combined with a negative 1 give me negative 4. The next one, they want us to multiply all these terms together, okay? Negative 3x times negative 3 times negative x times negative 1. So I could have looked at it as, okay, I'm going to multiply from left to right, okay? Negative 3x times negative 3 gives me a negative 9x, and then I just rewrote everything, okay? Then I multiply 9x times negative x. Net positive times negative gives me a negative 9. X times x is x squared. Then I multiply it times my negative 1. Negative times negative is positive. 9 times 1 is 9. And then I have my x squared. Or, from here, you might have said, I'm going to multiply my number parts together and then my x's together. Okay? So let's do it that way. Negative 3 times negative 3 gives me positive 9. Times negative 1 gives me negative 9. Okay? That takes care of my number part. X times negative x, positive x times negative x gives me negative x squared. Now I multiply these two. Negative 9 times negative x squared, positive 9x squared. So you could have done it one of two ways and gotten the same answer. Okay, this one says to graph all integers greater than or equal to negative 3. Integers, okay? So I don't put a circle somewhere and draw a line. If I draw the line, I'm including things that are not integers. So I did dots. It says it could be equal to negative 3, so I started here. Close dot, 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 dot. Bigger than negative 3. And then to show that it continues going this way, I put an arrow on this end of my number line. I can't put an arrow on that end because I'm not going to include those that are smaller than negative 3. Okay? So this is what your graph should look like on number 22. Number 25. 3 1/3 y equals 7 1/2. So I need to, first of all, get rid of mixed numbers. 10/3 y equals 15/2. What's happening to y? It's being multiplied by 10/3. How do I undo multiply by 10/3? Divide by 10/3, which means multiply by the reciprocal. So I'm going to multiply both sides by 3/10. 3/10 over here. These cancel, which is what I want. I just want y. 15 halves times 3/10. These reduce to and 3. 3 times 3 is 9. 2 times 2 is 4. So y is equal to 9/4. We're on number 30 now. Yep, number 30. So we start out with -3 minus -4 times +5 divided by -2. So this is order of operations to start with. So this multiplication comes first. -4 times +5 is -20. So now I have -3 minus -20 divided by -2. Well, now I see that I've got this subtraction here, but I want to change it. I want to add the opposite. So this subtraction turns to addition. Opposite of -20 is +20. So now I have -3 plus 20. Opposites, I'm going to subtract them. 17. Keep the sign of the bigger one. This one's bigger. +17. Divide by -2. And this should be, forgot my negative sign. 17 divided by -2 is -8 1/2. Okay, last one. -3 times +4 minus 5 times +6 minus 7. Well, hopefully you saw that this multiplication needs to happen first. -12 minus, then this multiplication. 5 times +6 is 30 minus 7. Now I'm going to get rid of my subtractions. I don't want to subtract, I want to add the opposite. Add, opposite of 30 is -30. I don't want to subtract, I want to add the opposite. Add, opposite of 7 is -7. So now I have all addition. Now I'm just going to add from left to right. -12 and -30 make -42. Plus a -7 makes -49. Okay. I hope you did well. Make sure you're keeping all of these papers and everything that you work on and check. Keep it all in your math notebook. If there's something you don't understand, please send me an email with the phone numbers I can call you. I hope you have a great day, and I'll see you next time. Bye.